Welcome ninjas to Code Ninjas Franklin. We are so glad to have you all in our virtual dojo here. We look forward to getting to code with you. I am Jacob Malloy. I've been programming for 9 years and I have been here at Code Ninjas since the beginning. I will be helping you guys to learn a little bit of JavaScript. We will go over the fundamentals in some short videos. That will be done by both me and Jacob Linkus, and we'll cover some fundamentals that are the same between Python and JavaScript. And then I will be taking you guys into coding some games such as Tron, Flappy Bird, and Tic-Tac-Toe in JavaScript using P5. Hello and welcome ninjas to our second little JavaScript programming tutorial here. We are going to be programming a Tron game. And if you don't quite know what that is, that's based off the movie of Tron, where they're driving around on motorcycles, leaving paths behind them, but if you run into someone else's path, you die. We are going to be doing a game where there's two players, and you drive around on the path, but if you run into theirs, you lose, and the other person wins. I find it extremely useful when I am programming to start out by drawing the scene, kind of getting an idea of what it looks like. So we're going to start out like that. We're going to draw our little square to be our screen, and then what we're going to do is we're going to make some markings on this. So the first thing to mark is that our width, I'm going to make 600, and our height is going to be 600. And then we are going to have players on the two players, so two little squares. We're going to do them as squares on the screen. So our green guy here is going to be player 1, and this guy's going to be player 2. As marking where it is, right here is the half point of the screen, so 1/2. This is going to be 1/4, and this will be 3/4, and both of these will be at 1/2 height. So that's kind of the layout of how our screen's starting. Of course, that'll change as the game goes on and as the players move, but that's how we're going to start it. So now what we will need to do, I think that's all we need here for now. If we need to draw anything else out, we'll hop back over here. But for now, we're going to hop on over to our code. So let's get to it. So as a reminder, you should have a tron.html with tron.js here. If you don't know how to do this, you need to watch the beginning JavaScript video. And then in our tron.js, we're going to have our setup function and our draw function. So for our setup, the first thing we need to do is create a canvas. Now we already talked about the size we want that to be. We're going to say 600 by 600. And we're going to get rid of that. Now up here, we need a var. We need a variable for where each of our players are. So we're going to say player 1, and we're going to say var player 2, right? So then we need to set where those are, but we have to do it after we create the canvas. Otherwise, when we do the width and height function, it's not going to work right. We talked about that in the Tic-Tac-Toe video as well. So we want to do player 1 equals, and we're going to do a vector, create vector, and where's our x going to be? Our x is going to be at width divided by 4, and our y is going to be height divided by 4, or 2, sorry, and we're going to get rid of that. And we can copy this for player 2. Yep, and all that's different here is this is going to be 3 times. Now, we can drop down in our draw. the first thing we're going to do is we need to set our background color. So we're going to say background, and I want it to be black for this one. So I'm going to do black. And then what we need to do is we need to draw these players. But how do we do the color? Well, there's two parts of the color. And the two parts is since we're doing rectangles, there's the outside of it, and then there's the inside of it. So you've got your rectangle, and then you've got your filling in it. So our rectangle is going to be stroke, and we need to set our stroke color. Well, we're going to do a RGB. So we already said, I'm checking my notes, we already said player 1 is going to be green. So red is going to be 0. 255 is our max green, and 0. All right. And then our fill is also going to be 0, 255, 0. And now we're just going to draw a rectangle, right? And our rectangle's position is going to be P1.x, P2.y. Our width is going to be, let's just say 20 for now. Our height, we're going to say 20 for now. And we're going to get rid of the rest of that. We don't need all that. So let's go ahead and check and see if that does what we want it to do. Beautiful. One down, one more to go. So now what we're going to do is we're going to take that, we're going to copy it out again. Actually, we need to copy more than that. We need to copy all of this. And we're going to change this to 255, 0. Remember, for copy and paste, you do Control-C and Control-V. If you're on a Mac, Command-C and Command-V. If you're on Linux, you probably should already know how to do that. I don't know how to do it on Linux. I'm guessing Control-C and Control-V. But Control-C is copy, Control-V is paste. In coding, I made a mistake here. This needs to be P1.y. In coding, it's okay to copy as long as it's your own code. Sometimes it's even okay to copy other people's code, but you want to make sure you understand what you're copying and pasting. If you don't understand the code, you should be including it in a library, just like we do with P5. Just some things to remember about copying and pasting. So we should get our red over there. Beautiful. So now there's a consideration I want you guys to make. And that is, we are going to be, when we move, we're going to move 20 spaces right now as it is, because the size of our guy is 20. So everything's going to be done in this, this scale. So what if we did everything in what makes more sense, at least to me, a scale where we're only doing 1, so we're counting by 1, but the computer knows what to do. So the way we're going to do that is we're going to create another variable. We're going to name it myScale. And we're going to set that equal to, and we're going to do 20 for now. And then up here, we're going to do, not right there. Up here, we're going to say scale. Let's put it below the background. Let's put scale, which is a P5 function, and it's going to scale everything after this by myScale. All right. So if we look at what this does, of course we have our error panel up here to see if anything goes wrong. Nothing goes wrong, but we lose our everything that's on there. So let's start out by thinking about why that could be. The first thing I want you to think about is right here we use width and height to set where our position is. But when we're scaling, we're changing the scale of that so that a width of 300 is not going to be on the screen. So let's make new variables, and we're going to call them my width and var my height. Right? So what this is going to do is, when we start out here, to get what those values are, we're going to say my width equals width divided by my scale. And we're going to do the exact same thing for height. All right, so now our positions are still going based off of this, so we need to change this to my width, my height again here, and my width again here. All right. Well, it's a little bit better. Of course, not much. If you notice, it's halfway down the screen, which is good, but our squares are huge. So the way we're going to fix that is, since we're scaling everything else, we got to scale our size of them. So we're going to do ones there and one here. So that makes it where the rest of this program, we can think in the scale of 1 pixel, 1 unit, is the size of our snake. Now, not our snake, our Tron path guy thing. 20 seems big to me. I'm going to be honest. I'm probably, because I think it'll make the game more fun, I may even do like 5. Let's see what that looks like. That actually probably looks good. Okay. So now, what we want to do is make them able to move, right? So something you got to understand about a little bit of how math works is you can give something a speed. And if something has a speed, what that means is each unit of time, so maybe it's each second, maybe it's every 10 seconds, you just add that speed to your position, and it gives you your new position. So if I'm driving at 10 miles an hour, after 1 hour, that's my unit, I will have gone 10 miles. Well, what we're going to do is we're going to create 2 more variables, and we're going to have P1 speed, and we're going to have P2 speed. Now we gotta keep track of speed in 2 different directions, X and Y, because they could be going up or they could be going right, or left or down. But we have to declare those down here. And the reason for that is because when we include that library, that P5 library, up here it's not necessarily in there yet, so we can't use that create vector. So we're gonna say P1 speed equals create vector. Now I want my player 1, I want both of them to start going up. So the way we're going to do that is we're going to say 0 here, and we're going to say 1 here. And actually it's -1 because we're going the opposite direction. Remember, up at your top is your highest number, or your lowest number, and down at the bottom is your highest. So even sometimes I mix it up. But where you go from 0 to whatever our width is, divided by our scale. So we're going to copy that, and we need a semicolon, so we're going to copy that. Awesome. So that's there now. So now what we need to do is we need to start adding our speed to our little guys. So the way we do that's pretty simple. I'm going to go down past scale, and what I'm going to do is I'm going to say P1 dot add P1 dot speed. It's not dot speed, it's speed. So the way this works is this is a P5 function, add is, that what it does is it takes P1 speed, whatever's in here, and adds it to P1 and sets P1 equal to that. That's one of the advantages of using vectors. We don't have to implement this on our own. So we're going to do p2.add, and we're going to do p2 speed. Awesome. So now, if we hop over, hopefully they move. First little issue I see there, it's not a huge issue, is that I don't like how fast they're going. So in this setup, what we're going to do is, remember, this draws every single frame. Your computer might run at, or your screen might run at 60 frames per second. You might be running at 120, but your computer might be running at 10,000. It's just how fast it can go. So what we're going to do is we're going to say frame rate, and we just set our frame rate here. So we're going to set it equal to 10. So we're going to limit it. And there it is. There it goes, moving. Now, I think would be a great time to start implementing, I guess, our movement so that we can control them with the keyboard. I want to start by using the arrow ones because they're a little bit easier. So we have this key key pressed, which is a built-in P5 function that is called every time a key is pressed. All right, and now, with this key pressed, what we need to do is we need to check each one. We're going to start with the arrows, which means we're starting with player 2, because I think it makes sense for the arrows to control the guy that starts on the right side of the screen, and the WAS and D to control the guy that starts on the left. But the arrows are easier, so we're going to start with that, and we're going to say if. Now there's key code is a variable, and we're going to say equals, and the reason I want to start with the right is P5 has up underscore arrow, all capital, and if it equals that, what we're going to do is we're going to say P2, because we're starting with P2, speed equals, we're going to create a vector, and we're going to set it equal to 0, -1, just like that. Now we're going to do the down case, so we're going to do an else if, and we're going to say key code equals, and we're going to say down arrow, and if it equals down arrow, P2 speed is a create vector of 0, 1. Now we could actually go ahead and go test this real quick, because they start going up and I can make them go down. That's awesome and all, but we need a few more directions. So we're going to say else if key code equals left, all capital, underscore arrow, P2 speed equals, and we're going to create vector, and we're going to say -1, so left would be -1, 0. I just realized when I do this, it's probably to the right for you guys, so let's say left that way. And we're going to have another else if key code equals right. I'm going to scroll up so that it's easier to see. Right. I keep not doing capital arrow. Then we're going to set P2 speed equal to create vector 1, 0. Now, I believe we should fully be able to move our right guy. So right, up, left, down seems to work pretty well. Now, what we need to do is we need to do the cases for the player 2. So I'm going to put a comment here and say this is player 2. And we need another section for player 1. And what we're going to do is we're going to copy this whole thing right into here. Now each one of these is going to need to be player 1. But the values here are going to stay the same. But we need to figure out the WAS and D. Now the best way I figured out how to do this is based off the ASCII table. So ASCII in computers, everything is stored as numbers. Technically as binary numbers, including letters and symbols and all that. So there's this table, the ASCII table, which has all of these different characters. So what we're going to do is we need W. So if we go down here, TUVW, and we go all the way over to decimal, we get 87, okay? So for our up arrow, we're going to change it to 87. Now we need the down, so that is S. So we're going to go back here. We're going to look QRS, that's 83. So we're going to do 83 here. And I had trouble seeing that because of my yellow cursor there, but now let's do left, which is A, which is right up here, which is 65. So for those of you who are paying attention, A starts at 65, and then every letter after it, all the way to Z, is just the next number. So that makes good sense. So A is going to be 65. And the right, so that's D. We're going to go right back here. D is 68. Now, of course, based off of A being 65 and thinking about what number each letter is, you could figure it out, but I highly recommend you just use a table because it makes it easier, and why not? So, if we hop back over to our code, once again, we always have our console up to see if anything goes wrong, but we can go right, down, left, up, right, down, left, up, left, down, right. You get the point. Of course, if we start it again, we can have both players playing. Of course, I have trouble doing more than the same thing on both of them at the same time. But there's that. And I know you're sitting there thinking, but Jacob, you told me that we were going to have trails behind him, and I don't see any trails. Well, actually, we can make that piece of our code really, really easy. So the way we're going to do that is we're going to take this background right here, which covers up anything that was already drawn with a background. Oops. We're going to copy it, we're going to get rid of it, and we're going to move it right up in here. So that only is going to happen once. So now, it works, just like that. Right? So, now that that's working fine and dandy, fine, what we want to do is we want to keep track, because we can't run into their trail or our trail, so we need a list or an array, whichever way you want to look at it, of everywhere we've been. So we're going to say var, and we're going to say, we'll just name this trail, and it's going to be an empty list. Now we're going to be adding a bunch of stuff to it. So what we're going to do is we're going to go on down here in this draw, right down here. And right before we do the P1 add, we're going to say our trail. And we're going to push. So we're going to push another value to it. And we're going to push P1. And we're going to trail push P2. All right. So now we should have a whole list of where all we've been. And actually, you can go in here and you can type trail, and it shows you that it's a whole bunch of vectors here, 136 to be exact. But each one should only occur in there once. So now what we can do is to tell if we've hit that. Let's go on down here. And actually, let's create a winner vector again. Or a variable, and we're going to name it winner. And we're going to say no one has won yet. So we'll just do a number this time because we'll have 1, 2, or 0. This one can't tie. And down here, what we're going to say is we're going to say if, or we're going to say for, because we need to go for 4. And this is going to be a big one, but we're going to say for let I, so for everything, so we're going to let I equal 0, so, and we're going to do I is less than trail dot length I plus plus. So for everything in that trail, what we're going to be doing is we're going to be checking if P1 or P2 is equal to that. Okay, so of course, this is going to be a long list. We saw that was 136 there, but we're just going to go through each one and check. So we're going to say if P1 equals trail I, and we're going to have another if P2 equals trail I. So if those equal that, we want to set winner equal to 2, and we want to set winner equal to 1. Okay? So what we could do to test this out real quick, so let's say our player 2 over here goes and just runs right on into player 1. Let's say winner, and we see that player 1 won. Okay? So what we need to do if player 1 wins is we need to stop doing all of this. So we're going to say this is if winner equals 0. And remember, you can highlight all this and press tab to tab it over. So now this will only run up until, oops. What did we do here? All right, welcome back. As you can see, I resolved the issue. There's actually 2 reasons that this issue occurred. The first one is right up here. We need to replace the trail.push P1 and push P2 with this. And the reason for that is a little bit more advanced coding issue. And what that involves is when we write code, our variables don't actually contain the value that we give it. It contains a pointer, a reference to where to find that. So when we said push P1 and push P2, we were not pushing the values, but we were pushing a pointer to where that was. So that can be a little confusing, and it's actually a little bit different how this works across different languages. That's why I got tripped up for a minute, is because in some languages it would be completely fine with that because it'll pass by value instead of by reference. JavaScript does not. So we have to do this little workaround where we create a new one by passing to values. The other issue is when we compare two vectors. Two vectors, even if their x and y might be the same, P5 stores other attributes of it, which means they won't be equal. So right here, we need to do p1.x equals trail I.x and p1.y equals trail I.y. I apologize for those confusions, but as a reminder, all coders make mistakes sometimes, and a lot of coding is debugging. So a couple things you need to remember when debugging: you can log things out to the console to see what they look like. That's how I ultimately found it. So let's keep moving. So where we're at right now is we have them both moving, and we can move them wherever we want, and we can kind of try to move them. I can't do anything about that other one, but you just saw one of our issues that we have with the code right now is they can go off the screen, ultimately as far as they want to go. So let's hop in the code and see how we fix that particular issue. So the way we're going to do that is we're going to use ifs, and we're going to look at player one first. So we're going to say if player1.x, and we're going to start looking at the x direction. Now there's two cases where x can be off the screen. One, as you remember, the rectangle draws in the top left-hand corner and then draws so many down and so many over. So to be off the right side of the screen, the x has to be greater than or equal to the side of the screen. So we're going to say p1.x is greater than equal to width. And this needs to be my width. Now, we're going to do an or, because it can be any of these cases. So we're going to do an or. We're going to do the same thing. Now, to be off the screen on this side, we would have to be over 1 minus 1. So let's do less than or equal to my width minus 1, or minus, so we would need to be at minus 1, because this is going to be 0, so that's how that's going to work. Now we need to do off the top. So off the top is going to be the same type situation. We're going to say p1.y. It's going to be the same type situation as I point at, like you can see where I'm pointing. It's going to be the same situation as this one right here, where we're going to say less than or equal to -1, or p1.y is greater than or equal to my height. Awesome. And in that case, we're going to set the winner. If player 1 goes off, the winner is 2. And we're going to do this exact same thing. Player 2, player 2, player 2, player 2, and 1. All right. So now, if we play it, and let's say this player goes off the screen here, someone wins, and we can check here, see who wins. So player 2 went off, so player 1 wins. Let's try with player 1 going off. So we'll go like this, and we'll have him go just like that. And if we do winner here again, we get 2. Awesome. Exactly what we would expect. And now we have a pretty much fully functional game. And at this point, I'm actually going to leave it to you. There's a couple steps that you guys can make. I've got 3 different things that are of 3 different challenges. The first thing that I would like to see some of you try to do is just change the color. Change the color of these guys, perhaps to your favorite color. You can even change the color of the background. I'm looking forward to seeing some pink, some purple, some orange, maybe even white. Tron players, blue. I always like blue. Maybe you should different shades of blue. But experiment around with changing these numbers right here and here. You can even go online and find a color wheel and play with those. That's the first challenge. Second challenge is in the tic-tac-toe video, we made a this player wins screen. We already have the start of this because we have if the winner is equal to 0, so we just need an else. So we would have an else, and this is the second hardest one to do. Else, well, it's all going to be else. Tell me who wins. Do something to show who wins. And you actually, one little note, might have to change this scale. You may want to change this scale to 1. Now, you cannot do that and see what happens to understand what happens there, but that's a little tidbit I'm going to give you. The last challenge, I said I was going to give 3, and each one gets a little bit harder. This one's quite a bit harder, is make it more than 2-player, maybe 3-player. Now, the challenge there is if one person runs into themselves or goes off the map, that doesn't end the game. You still don't have a winner. So you're going to have to keep track of who has gone off and all that. But that is the most challenging one that I think many of you might be able to do. But until then, I'm going to go ahead and sign off. I look forward to seeing you guys next time, and I look forward to seeing what you do. As always, if you have anything that doesn't make sense, go back and watch the fundamental videos. If still doesn't make sense, you can send us a message. You can send us a comment on the video, and we'll either address that in the comments back to you, or we may need to make another fundamental video on something. Maybe we didn't explain something that might be confusing. One more thing I just thought is for the first one, for the resetting the screen, you're going to want to have a background something here. So I'm going to temporarily put background 0. I'm just thinking there's a couple things that are very difficult that if you run into them to figure out what's going on, that's one of them. So until next time, I'm signing off. I would like to remind you that if you need a refresher on the fundamentals, there is some videos in the description to help you out. We will be updating those occasionally. Also, if you have any questions, please leave them in the comments and I will try to check them for you.